In this final episode of the season, we're joined by Dr. Victor Nian, founding co-chairman of the Center for Strategic Energy and Resource. We will unpack the complexities of the global energy transition and examine the roles of how hydrogen and nuclear could play in shaping a sustainable energy future.
Welcome everybody to another episode of Maxwell En-Route. And we're in a season where we're discussing the issue of sustainability. Rounding off the series today with us is Dr. Victor Nian. Dr. Victor is actually founding co-chairman of the Center for Strategic Energy and Resource. His expertise is in energy and nuclear policy, energy systems analysis, technology assessment, and integrated solution development. And he's a founding member and elected council member of the International Society for Energy Transition Studies and was previously visiting fellow at the Hughes Hall, University of Cambridge. Thank you, Dr. Nian, for joining us today. Really privileged to have you here.
It's a pleasure to be here. Thank you for having me this season.
Yeah, so we've been having this conversation with other people about sustainability, and the topic has basically covered quite a few areas, including the issue of climate change, public perception about what they can do, and where some of the changes are really greatly needed, and so on. But for you, we want to focus more on the issue of energy transition, which is your expertise, because I think one of the big issues that we have is people can easily point a finger at some of the sources of our energy today, coal and other fossil fuels, gasoline and so on, and say this is going to lead to our planet dying and all of us dying on the planet. So we should stop this right now. But of course, that's a very extreme kind of solution to the problem where you just cut off everything. I mean, is that even possible? What are the implications if we turn off every coal power plant today and we stop burning gasoline? I mean, what will society look like?
That is a very good question. When we talk about energy transition, very often people talk about where we are transitioning to, right? So we want 100% renewable, 100% clean energy. We don't care where that clean energy really comes from. We just want to make sure that there is no fossil fuel. So the final destination is already defined by environmentalists or environmental organizations. They think this is where we should go. But you seldom hear people talking about where we are transitioning from. And to me, that is the most important. And if you look back into history, industrial revolutions, the first one, the second one, all based on fossil fuel. There is no historical industrial revolutions, inventions, and discovery of physics that's based on renewables. Some are, but the fundamental part is a fossil-dominant or fossil-driven economy that has brought us where we are. Right. Modernizing the economy, buildings, comfortable buildings we live in, the electricity, we don't even think about where that really come from. Wherever we go to home, we switch on the power, we switch on the lights, we expect the lights to come on. We don't think about where it come from. Right. And then all of a sudden we realize, okay, carbon dioxide or greenhouse gas emissions, these are the devil that is going to bring us a doomsday when climate change happens and disaster all strikes. And we say, okay, time to put it to a stop. But to your question, can we just cut it off? From an environmental point of view, yes, we want to get rid of this as soon as possible so that we can reduce global warming effect. We can also save ourselves from the dangerous consequence of climate change. But environment is not the only thing in sustainable development. And in fact, in the sustainability triangle, we talk about people, planet, profit, right? And the thing about planet, it comes at the end. Yes, you can say people, planet, profit, but always when we say energy transition or sustainability, people is at the forefront, meaning that if this sustainability or the sustainable development pathway has somewhat forgotten about the people element, that is where we probably will kill more people than the climate or the environment do. So think about this fossil fuel example. Right? If you think about the whole global supply chain, and we look at where the world, and also looking at Southeast Asia, where we have a huge dominance of fossil fuel, which sector is employing most of the people? And more importantly, low-skilled workers is the coal mining industry. Right? It's the fossil fuel industry, it's the natural resource industry, the mining workers, the workers that drives the truck, lorries and everything, right? So these are the sheer majority of low-trained skilled worker that will be suffering if we are really going to put a handbrake. That's it, tomorrow, no more fossil fuel. And what does that mean in the regional context? Let's not talk about other countries, just in the Southeast Asia region.
Sure.
That means millions of jobs will be eliminated all of a sudden. And these millions of jobs, it's not like, okay, today you and I, maybe we are trained technical professionals. We may be engineers and scientists, legal professionals. If, let's say, there is a diminishing demand of one part of the world, we can always retrain ourselves and learn something else. Right? There is also this discussion about training manufacturing workers into AI engineers. I hope they can do that. But can we retrain a coal miner to become an AI scientist, and that this person can operate a computer and start coding? Very likely, this is impossible. And what it means is that before global warming or climate change starts to kill us and those that lives in the coastal areas, we are already killing off the lifeline. I mean, these are the breadwinners for the family. So what does it mean if you just go out of fossil fuel?
That's interesting, because so what you're saying is that we are not ignoring the fact that if we carry on this trajectory of emissions, we are going to kill everybody at some point in the future. But the way we address this can also lead to other short-term pain that is not good either, which either involves people losing their jobs and so on. And I think also sometimes it's missed that why do we have energy in the first place? It's not just to power your phones so that you can talk to people or to watch Netflix, but it's part of how you produce food and deliver food to people, where food doesn't magically appear on our plates. Someone grew it somewhere and prepared it and transported it to a place where we could then buy it. And all of that needs energy. And then medicines, the production of all of these things, running hospitals. Sometimes, it's lost in the conversation for sustainability that the energy is something that is critical in our lives. And we cannot just suddenly say, we'll stop using energy, which is why the conversation is where it is for you, which is we should not talk only about trying to move away from carbon emissions. We should talk about, okay, what then do we replace this with? What is the way we're going to get our energy from? I mean, of course, we should reduce where we can, but some things you can't. I mean, you can't stop people from eating. You can't, say, well, in the middle of an operation, we're going to turn off the lights in the hospital because it's Earth hour. You can't do that, right? So there are some things which we need power for. Where does the power come from? So I think that's something that you've been working on and studying, where people are generating power from pollutive sources. And let's see whether we can eventually move to something else. So what are some of these other sources that are, viable, commercially sound? Because, some things may be theoretically possible, but they're so expensive, or the technical challenges are impossible that it's not feasible. What are things which are commercially within reach of us transiting to?
Yeah. So, of course, if you look around the technologies that we're talking about in energy transition, right? So first of all, with the fossil industry, then of course, coal power plant, gas-fired power plant, these are very much well known by us, even by the general public. We know that coal can produce electricity. And of course, there is nuclear, probably infamously known for accidents, right? Chernobyl and then Fukushima, but people know that, okay, that's also one source that can produce electricity. The more intuitive ones, of course, are the renewables. Why I say intuitive is because human society went through industrialization. We were all using renewable energy. First fire came from renewable source, right? Lightning, right? And when we started to learn how to use biomass, we all think that's coming from the natural system, the biological system, but actually everything comes from the sun. Right? Without photosynthesis, there is no bioenergy. There's no biological source whatsoever. And of course, now with new inventions, we can produce electricity from solar. We have the solar panels. We also have the solar thermal. So in the old days, we all have this like a satellite dish size kind of device where you can actually boil water from the satellite dish. That's actually solar thermal. Then, of course, wind turbines, using wind so we can produce power. Hydro, right? That's hydroelectricity is also quite well known, well established many, many years ago. So all these variable technologies that are already commercially proven. But there is one challenge with the renewables. Although we think they're nice, they don't have any carbon emissions when we are using them. During operations, no emissions. Of course, if you talk about life cycle, that's a different story. But I think for now, what I would say is, although these renewables are plausible, they are really great, saving the environment, bring green electricity, not everybody or every country have equal access. For example, I talk about hydro, right?
Right.
Hydropower is deemed to be the most cost-effective,
Yeah.
in fact, almost cheapest.
Yeah.
But you can only have hydropower if you have the proper geographical circumstances. Say, for example, along Mekong River in Laos, in East Malaysia, Sarawak, yes, we can have really a lot of hydropower. But then if you look at Bangkok, we look at Singapore, we look at Kuala Lumpur, these are the places where we absolutely have no hydro. So then that becomes a challenge. So for these places to have hydropower or renewable energy, it becomes a lot more expensive as compared to people who just live next to the hydro dam. Right? So that uneven access to renewable resources also creates the challenge about, for example, price of access, challenge to access. And then, when we talk about scaling up renewable energy, what does that mean, right? Is that really a just transition where everybody, let's say just regional context, would have equal fair access to all renewable energy resources in the region? The answer might be no for the short term. So this is what we're facing. Renewable energy is good. We really love it. But then, of course, another technical issue is hydro is difficult. What about solar and wind? Right? This is more popular, right? So wind, most places have it, but of course, not everywhere in Southeast Asia you have wind, right? Offshore of Vietnam, Philippines, and maybe Indonesia, some part of Gulf of Thailand, you have wind. But in Singapore, no, absolutely no wind power. But solar, yes, now it's getting more popular. Everybody is doing solar. But the challenge is the fact that it's called a solar panel. It means it doesn't produce electricity when the moon is in the sky, right? It's not called a lunar panel, right?
Or even a cloudy day.
No, it's a cloudy day or rainy day, right? And also if the weather just don't work for you, for example, on a very humid afternoon, you have a cloudy but humid afternoon, but still very hot, 35 degrees. You have a peak electricity demand, but your solar panel doesn't work. So what happens is you are actually amplifying the damage from the fossil fuel plant because they have to work harder to compensate for the lack of renewable. So all that and part and parcel of the issues.
I did find it funny that you mentioned under this conversation of renewable that burning biomass is considered renewable. So why wouldn't you consider fossil fuel renewable, coal and gasoline and oil? Wouldn't that fall in the same category that came from the sun at some point? And then
yes, all fossil fuel came from the sun.
So in theory, when I drive my car, I'm driving using
it's a renewable
source, isn't it?
Yes, exactly. So this is an interesting point that people also don't want to talk about. So when we talk about renewable, we always put on time scale. So on what time scale can this particular resource renew itself? Yes.
Right.
And then we say, okay, because these are plants and everything, so photosynthesis happens every day. So technically speaking, you are trying to replenish every day. Although the scale is a different question.
Sure.
Can fossil fuel be renewable?
Millions of years.
On the geological scale, yes. If you're talking about geological timeline, yes, it's renewable. So
that's why maybe we don't call it renewable, because it's not a meaningful time frame for us to consider that the fuels can renew themselves. And I think the bigger problem remains not so much about whether it's going to run out, but the fact that it's pollutive. And I think that's a big question of why people are talking about some of these other sources. And I think it's interesting now that we are talking about things like solar and hydro and wind, which are the traditional ideas of power coming from the source of the sun. Actually, it's all the sun. It's all from the sun, because the sun is the one that brings water to various parts, and therefore when the water runs, you can get hydro. But it's all really the sun. But here's the thing that we will also you mentioned briefly, which is nuclear, and also about hydrogen, where this is something which I just want to clarify with you, where there's a difference between a source of energy and a means of transporting energy. Where like one of them, which in the case of nuclear, is that you're actually generating electricity from the isotopes that you are either breaking or hopefully combining at some point in our future. But hydrogen is not naturally occurring where you can just pump hydrogen out of the ground. So it's not really a source of power, but it is a way that you could use to transport power by producing hydrogen somewhere else and then storing it in a vehicle, for example, or a plane or a car, and then using it to power the engine. So it's a way of transporting a vehicle, which is still useful, because that's where we have all the jet fuel and gasoline that's polluting the air. But having said that, the interesting thing for me is that hydrogen, first of all, is a known fuel. It's been used before in the past, and it generates a very clean waste product, which is water. it doesn't produce carbon dioxide and so on and so forth. So it sounds like in the age of sustainability, it's like a perfect fuel, and it's not new. So you cannot say that, no one knows how to use it, right? But why don't we see hydrogen cars? Why don't we see hydrogen planes? I mean, what's going on? Why are we not going more into hydrogen?
Yeah. Well, the idea of hydrogen, you're right. It is a very old or rather ancient idea, right? In fact, today, all the rocket engines are built around hydrogen, right? Every single launch, you see these beautiful flames. Those are all the work of hydrogen. So it's proven. I mean, it can send satellites into space. Definitely it can be made useful for human being. Mm-hmm. So, of course, the whole idea about hydrogen came about in several cycles, right? I mean, in the early 70s, we talk about hydrogen. 90s, we talk about hydrogen. 2000s, we talk about hydrogen. And now, people are betting really big hope on hydrogen. Why now, right? Mm-hmm. So the question is, can we properly govern the use of hydrogen? The answer is definitely yes. I mean, we see hydrogen everywhere. It's even in our town gas in Singapore, we blend hydrogen into it. Mm. So the bluish flame you see is because we have hydrogen in it. So we can safely use that, but only a very small percentage. Okay. Now, if you talk about hydrogen cars, hydrogen trucks, or hydrogen buses, or hydrogen flights, there we talk about 100% pure hydrogen. And that is a totally different world of engineering. Okay. It is not the conventional thinking, we can, like the old days, we phase out gasoline, we want to convert to CNG cars, right? Singapore has once done it, but we face challenges. The one major thing is infrastructure, which is refueling station, right? There was only 2 refueling stations at the time, and there was a long taxi queue, and nobody wants to do that. It died a natural death.
But that's different because that's an economic and commercial challenge. If there's enough demand, at some point you will be able to catch up with the supply, right? But are there other problems with hydrogen that it's not related to not enough pumping stations?
So I'm getting there. So of course the demand has to be there. Right now we don't have it. We're hoping that we'll be able to push up the demand. But right now the challenge is we have the technology to produce hydrogen by splitting water, right? And we say that, if you have enough renewable energy, we can make the electrolyzer cheaper. We can produce hydrogen at a really good price. Okay. That we understand, and it's being done, right? And also the refinery can also create hydrogen. Right. They do that on a regular basis because all our plastics, everything needs hydrogen. Now, so the supply side, we don't seem to have an issue. Now on the demand side, hydrogen vehicle also has been around for a long time. Early in the 90s, there has been prototype hydrogen cars. There was actually, I think, one in Singapore, long time ago. There was one hydrogen car in Singapore. It runs, it's a proper car. Not a prototype or anything, it's a proper car. But it was noisy, of course, this old-day technology. Sure. But of course, today with hydrogen fuel cell and all that, Toyota Mirai has been selling, hydrogen fuel cell cars. But of course, sales wasn't great. I mean, they sold about 100,000 cars in a very long time, 10 years over. So, but they also said that technology is proven. Okay. And we talk about gas turbines for power generation, they can also use hydrogen. Industrial boilers using hydrogen, no brainer, right? Green steel, so-called using hydrogen as fuel and also as a reactive agent, and that's also a proven technology. So demand and supply side are both okay. What's missing? So what's missing is everything in the middle, the supply chain. Meaning, who can deliver hydrogen from the source of production, say in places where they have a lot of wind in Europe, and bring those hydrogen at reasonable cost to Singapore port. Okay. And what are the infrastructure do we need? So first of all, we need to have a demarcation terminal, meaning you need to have a hydrogen terminal somewhere in Europe to load hydrogen onto a ship. And that ship needs to ship hydrogen at minus 273 degrees. We call it absolute zero. And that is one thing that's very expensive.
Why do we need to transport it at minus 273? What is the problem with transporting it at a different temperature?
So if you are transporting LNG, we are transporting at below 100 degrees. So that is still, at that temperature level, it is still okay. It's manageable. With normal cooling systems, it is not too difficult. Of course, it's expensive because you need to maintain the temperature in the process, burning a lot of bunker fuel. Right. But with hydrogen, you're going from 100 degree, minus 100 to minus 200. It is not the same effort as you cool from room temperature to minus 100.
Yeah, no, but why can't we transport hydrogen at minus 100? What happens if we do it at that temperature?
If we do, the reason why we want to transport hydrogen at that temperature is because we want to transport hydrogen in the liquid form, so that we can maximize the volume.
And if it's not at the temperature, it will be still in a gaseous form.
You'll be in gaseous or maybe two-phase, meaning some liquid, some gas. Okay. One thing is it's difficult to control in this state physically. Okay. Right? Second thing is because you're talking about volume, that matters more to the transportation via ships.
So you
want to
can't
pack
store
as much as
right?
Yeah, exactly. So at liquid hydrogen, you really can transport the most amount of hydrogen with one shipment. But then of course in the process you burn a lot more bunker fuel and you have to cool it down. So you need to have properly designed vessels. Right now there are one or two, but we don't have commercial vessels that can transport liquid hydrogen at scale.
Okay.
Coming to Singapore, we also don't have a proper receiving terminal. So it's not like hydrogen come on shore, you use it straight away. You need to store it, and you need to have a distribution network.
Okay.
That doesn't exist today. So you need to invest a huge amount of money to build those infrastructure. And the amount of energy you spend during transportation is also the amount of energy you need to spend to store hydrogen in the same condition.
Are there other problems with transporting hydrogen at a higher temperature besides the fact that it's not as efficient because it takes more space? Are there any other issues?
So if you want to transport hydrogen in a gaseous form, it's possible. There are compressed hydrogen gas cylinders that people are transporting. But of course, if we don't talk about the economics, we just talk about other issues.
Right.
The hydrogen, is a very small molecule. It is the smallest molecule we find known to human
H2,
being.
yeah.
H2, yeah. So it has very specific or special chemical or chemistry or physical property. It is the metal embrittlement. So in gaseous form, hydrogen tends to seep through the gaps in between atoms. So even though you may have a well-sealed gas tank, like a stainless steel gas tank, hydrogen can still just come out without you knowing. It's a very small amount.
Wow.
Yeah, it is not dangerous. I mean, that small amount is something you can neglect, but the damage done to metal cannot be neglected. So if you don't do regular inspection and maintenance, if at a point where the metal becomes really crisp, it will may lead to cracks, leakages, and that can potentially lead to a hydrogen explosion.
Which means that actually hydrogen, if I could just summarize, hydrogen damages its own storage container over time, which means it becomes more and more dangerous the longer you store gaseous hydrogen in metal. So, wow, okay, so that I think immediately illustrates why you can't really do it that simply, because even if you had a car, the car itself would need a hydrogen tank. And over time, that tank, which you're going to be driving, with it behind you, is going to be more and more dangerous.
You need to change the tank at some point.
Right. Okay. So I think that clearly illustrates one of the challenges with pure hydrogen. But you alluded to the fact that we add hydrogen to other things. What does that mean, actually?
So for town gas, I give you the example, right? We blend about 2%, 3% to increase the heating value of the town gas so that they're more heat efficient by the time it comes to us. And we're also saying that because hydrogen has all these metal embrittlement issues, if we do a blending, these issues can be addressed significantly. So rather than using 100% hydrogen as power plant fuel or industrial fuel, let's say we only blend 10%. So that may not lead to that much damage or fast degradation of equipment as compared to using 100% hydrogen. And in the meantime, it's also like a pathway to move gradually to 100%, and if and when we are ready.
Right.
So that is happening, and it's possible, and it can be done. But then again, hydrogen as a molecule, to use it as a fuel, the viability of doing so is a question mark because of the physical properties, the critical conditions to store and transport, and we haven't talked about the conversion efficiency of hydrogen, right? Okay. So we should talk about this. Yeah. If you think about solar, let's say today maybe 15% efficiency converting from the sun to electricity. Yeah. Then let's say we use solar to produce hydrogen. That give you super efficient electrolyzer, maybe 45%, right? And then during transportation, you have a huge losses. Let's say that give you another 20%. Down to shore, you also need to put the hydrogen into some end use, let's say into vehicles. I give you a 50%, actually it's much less, hydrogen fuel cell efficiency, right? Then with all the frictions and everything losses, you're looking at 2% from the sun to the wheels in Singapore.
I see.
Maybe less than 2%. So the question is, with all this tremendous amount of effort, we are only getting 2% overall energy efficiency. So what are we talking about with hydrogen, right? Should we really consider hydrogen, knowing it is so difficult? Or maybe we should think about some other solutions.
Right. So what I'm hearing from you is that because we are using power from the sun to make hydrogen, but because of the loss of the power at so many stages that it takes to get to the actual vehicle that's moving, why don't we just take power from the sun and use electricity?
Exactly.
And that's far more efficient in terms of energy loss. And I suppose when we talk about things like, say, batteries that are heavy, which is why it's been difficult to design an electric plane, and even drones have a limited flight time and so on, because the weight of the battery is a real challenge. So people have proposed maybe if we can figure out hydrogen planes, then we could really just use it as a substitute for aviation fuel. But I guess maybe that's why people aren't putting that much effort into studying that, because the sense that you could eventually design an efficient, commercially viable hydrogen plane, the amount of R&D that it will cost to go in that direction, you might as well put that into already a fairly advanced body of knowledge with electric motors and batteries and so on.
Or maybe biofuels.
And biofuels, so that you actually design further what we already have, refine and tweak and enhance it, rather than we try to go down this road which has an uncertain outcome. You're not even sure you're actually going to crack this hydrogen fuel problem. So is that why maybe the research priorities are not really in that direction?
Yeah, so which is why, although we are interested in hydrogen, because for Singapore perspective, we import fuel one way or another. So likely hydrogen will also be importing. Okay. So to Singapore, it's not really a major difference.
Sure.
But then from the perspective of whether the overall economics works for the whole world as a global hydrogen ecosystem is a huge question mark. So not many countries are really serious in hydrogen, because there are many other alternatives. Right? Biofuel is one thing, is much less talked about, but now people are talking about it. If you're coming from biological source, even though you might use our existing infrastructure to produce biofuel, there's nothing wrong with it. Because everything is biogenic. So rather than trying to crack really hard on hydrogen and have all these losses, at the same time having safety risks, and not to forget, a lot of these safety risks that we talk about today are not only there are physical risks, these are also perceived risks. Because from young, we do a hydrogen experiment, right? So, in primary school, we already know hydrogen is a highly volatile gas. And we see Fukushima is a hydrogen explosion, right? So we don't think hydrogen is dangerous, right? So this, from the mental part, sentiment-wise, we say, oh, this is not safe, right? So maybe we should look at other things.
Right. I mean, of course, and the very, very graphic picture of the Hindenburg burning up, filled with hydrogen, in Germany. So that's another one of those. So when you say bio mass and biofuels, I'm assuming that you're not referring to like people who grow corn and then turn it into ethanol, but we're talking about like, say, other industrial or other processes in society that you already generate waste and you're going to have to dispose of it anyway. Can you see whether you could do something with that waste to try to extract some kind of biofuel out of it, rather than you try to, just throw this away and then produce fuel from some other source? Is that what you're referring to?
That's exactly the point. So two of the most common source of bioenergy or biomaterial. One is, of course, from wastewater treatment plant. Okay. There you can produce a lot of biogas, right, from it. And then the other part is really the animal farms. That is where natural methane all come from. And also agricultural residues. Normally people will burn, in major agricultural land, they will just burn the residue in the land itself, and then that becomes fertilizer. Okay. So in a way, it's a biogenic part. But if you don't do that, what you can do is like palm kernel shell, right? You collect them, and they become the natural power plant fuel. Because otherwise, you throw them away anyway. Sure. So might as well recycle them, so to create more energy out of it. So yeah, that is the idea of a proper biofuel. Okay. But then again, you can already tell that there will be a problem with scale. Right? How much waste can we really produce if you are using them as a power plant fuel? Okay. Right? So then that's why you have the issue of people growing corn for methanol rather than growing corns to feed people. Sure. Yeah, because there is a price to gain. There's an economic benefit. So it kind of sway the industry there.
But I suppose at the margins, you can get some of your energy from the waste and some of it from elsewhere. It doesn't have to be all or nothing.
Exactly.
And it can solve the problem in small ways, and enough small things happening, you can move the needle, I suppose.
Yes.
So that brings us actually to because you mentioned about the psychological issue of people saying, oh, hydrogen's a bit too dangerous, let's not touch it. Then we have the big one in the room, the elephant, nuclear. So nuclear itself has, just because human beings are like that, we don't actually make the effort to understand something well enough. We just read the newspaper and we see a headline and we're like, oh, this is terrible. But actually, that could be a once-in-a-lifetime kind of situation, and it skews our perception of it. So the sense I feel is that most people feel like nuclear is not safe. And it's not safe enough, at least, to be near me. If it blows up somewhere else, and I couldn't care less, but not in my backyard, right? But that becomes a big issue because a country like Singapore, as you pointed out, we don't have, wind, we don't have hydro. We actually, surprisingly, we don't have as much solar as people think we do, because people think Singapore's so hot, we must be able to get solar, but it's incredibly cloudy. And we know that because in Maxwell Chambers, we actually have installed solar panels on our own building, and we're monitoring the amount of energy we get. And there are entire months where it's like rain and rain and rain. So we don't actually have access to these kinds of renewables. And all our energy is like imported, as you pointed out. The 95% is natural gas. So from the issue of not just sustainability, but energy security, to be able to ensure that if something goes wrong, we at least have some way of powering the critical systems in our country. It all seems to come back to nuclear as an option. And in fact, the government is, sort of slowly trying to get the word out to say we're studying it. We haven't made any decision yet, because it's sensitive, but we're looking at it. Why do you think that nuclear remains something that's so controversial when actually the science, in my opinion, from what I've read and understood, the science seems to suggest that it actually is a lot safer than people think it is?
Yeah. So the first time we learned about nuclear, when we were all young, is The Simpsons. So whenever you watch The Simpsons, what you see is this: you will glow in green light, and the nuclear power plant glow in green light. It's only a matter of time before the nuclear power plant turns into a nuclear bomb and just eliminate everyone. Right. And don't forget, you have all this slimy field of nuclear waste in liquid form that is also glowing in green.
Right.
So I always tell my friend, well, if, let's say, remotely what they said is correct, at least one thing they didn't get right is the color. The color should be blue, not green, right? If you've ever been to a nuclear research reactor, these are all the open pool type. You can actually see uranium that is undergoing fission process. And in water, it glows a really cool blue light. The first time when we saw blue LED, that was cool, right? It was a really cool invention to see a blue LED. All of, it's only green and red. You only have two colors. And now we have a blue LED. So that's the color you get to see in the operational nuclear reactor.
Right.
And it's really nice. And you can actually just go over and look over it. There's nothing wrong with it. So, but the thing is, how many people get to know this is the case rather than, saying, oh, no, nuclear power plant is just a time bomb.
Right.
And then the next thing everybody know because of Cold War, 1986, Chernobyl, right? And they say that, all nuclear power plant is just waiting to become the next Chernobyl.
Okay.
But then when you start to talk about technology, they switch off. It's just way beyond them.
Yeah.
And then there's Fukushima.
Yeah.
So we say, technology is not relevant, but the Japanese technology is a lot more advanced than the Soviet. They also have done all the safety checks and everything. And by the way, this is American GE technology.
Yeah.
The fact that it was done in the 60s, no, we don't care. It's a new tech. It's a later, a safer technology. And don't forget, Japanese, Japan has a really, really good regimental process, and they have a proper nuclear regulatory framework in place to govern safety. If Japan couldn't do it, now the region wants to go nuclear. Can we do it?
Right.
Then, of course, after Fukushima, a few years after that, the Diet of Japan published a report on what went wrong.
Yeah.
Right? That has to do with the culture itself, not challenging your boss, and also with the issue of the lack of communications, the delays in chain of command and everything, and also the fact that there were recommendations made by IAEA, but it was not implemented. That all part and parcel contributed to that. And also, they said, the battery worked, but didn't last until the time that they wanted. The backup generator was flooded. And what that means, so if you go behind this story, rather than saying it would just be bad, you go behind the story, you think about it, you would need a huge earthquake followed by a really devastating tsunami, and to cause a station black, we call it station blackout, meaning no power in the nuclear power station, and to have the battery drain. Today we are oversizing the battery already, and to not have the backup generator working, and also don't have access to offsite power and offsite generator and the grid, and that you have delay in fire brigader coming in to do cooling, then you have Fukushima.
And you have to have a design of a power station that is from the 60s.
From the 60s. And you see, you need so many things to happen all at the same time
Right.
to give you Fukushima. And actually, every step of the way, there are ways to mitigate.
Of course.
Actually, there is a simple solution. But of course, we all think that that's the least desirable, which is basically open the floodgate, just flood the nuclear reactors.
Flood the core, basically, right?
Yes, but TEPCO wants to salvage the equipment because once you do that, then that means goodbye for all the foreign unit. That's 4 gigawatt of assets. That's a lot of money spent.
Yeah.
So of course, TEPCO as a company wouldn't want to make that decision. By the time the Japanese government made the decision, it was already too late. Fukushima already happened. But then again, you see, the media has always been saying this, nuclear reactor, you will have a hydrogen explosion, and then you have the radioactive plume, and then part of Japan is, polluted. And then if they're discharging the water, then the whole world gets polluted. But one thing also not many people noticed is that when the earthquake happened and the tsunami washed on shore, right, the entire Fukushima village was destroyed. Then you have shipwrecks and all these things from the sea that was crashing onto the nuclear facility. But all 4 nuclear buildings, none of them collapsed.
Mm-hmm.
They didn't even suffer major damage.
Mm-hmm.
So, if you are really an informed citizen, when that happens, you will run into the nuclear building to save yourself. You don't run away from the waves. You run into the nuclear building. Yeah. For sure, you'll be alive.
Yeah.
But then, the media never said anything about this, and just say that this is something waiting. Is again a time bomb. Right. So you do it in Singapore. We also. It's perceived that we don't have nuclear capabilities,
Sure.
right? So how do we govern the safety of nuclear? And worse still, people relate engineering capability of nuclear to our MRT trains. And they say, well, we have breakdowns all the time. If there's a nuclear power plant, are we going to suffer from the same?
Yeah, so what I'm hearing from you is basically it's not right for a person to draw a conclusion from the Fukushima accident and then therefore just put a label on it to say nuclear is dangerous, because actually that was like a perfect storm of so many things happening at once, which are almost impossible to repeat anywhere else in the world. Like you said, there was an earthquake, a huge earthquake offshore, followed by a huge tsunami, which many places have earthquakes without tsunamis. So even those two itself already are a very rare combination. And the tsunami itself wiped out Fukushima town. But the reactor itself was standing, except that they lost power, which, so power loss is, of course, an issue. I mean, we just saw that at Heathrow Airport, of all places. But the reality is that there are ways that if you take care, you could mitigate that, as well as the fact that there are nowadays newer designs for passive safety systems that don't actually require electricity, where and as you said, even the electricity itself was not the final nail in the coffin. It was the decision that if we can salvage the reactor, we should, because that's still got so many years left of power left in it, how much money we can earn, rather than we make that fateful decision to flood the core and we have to write off this whole asset. It was a commercial decision that was wrong, because they underestimated how bad the problem was until finally, when they were forced to do it, you couldn't really save it. So I think that's a very interesting explanation for why we shouldn't be so quick to pick out this one disaster scenario and then say that all the other nuclear plants out there, therefore they're all similar accidents waiting to happen. Because, for example, France has been running on nuclear power for a very long time. The US, and there's been no problems. And even for people who have issues with a nuclear, sort of source so near to us, we forget that there are military nuclear vessels that are pulling into our harbors every other month, port calls and stuff like that. So the reality is that nuclear, and in fact, the nuclear ship itself is a nuclear reactor that's sailing around everywhere around the world. And again, you don't hear of stories of ships exploding and things like that. So the reality is that actually this is something which maybe we have a oversized fear of it. But when we begin to understand the issue better, it may be something that we begin to say, well, actually the trade-offs are something that I think are worth considering seriously, because it's not as though we are saying that, well, if we don't use nuclear, then everything will be fine. Maybe we have to pay more. We're talking about globally, the world is struggling with the issue of climate change. And if it doesn't mean that if you don't touch nuclear, things are going to be fine. They're not. And maybe nuclear is one of those things which you have to say could actually be a very important part of the overall picture of addressing climate change in terms of the emissions that we generate.
Yes, and exactly the point about 24/7 carbon-free energy. This is what data centers are asking for, right? 24/7, why 24/7? Because data centers, hospitals, industries, they operate 24/7. If you only rely on solar panel, well, who's going to provide that kind of electricity at night, right? So inevitably, you need something that is more controlled, that also offers you, like you refer to, energy security, right? And that's also from The Simpsons. They think that there's a huge mountains of nuclear waste from the nuclear reactor, but in reality,
tiny barrels,
what you get is really tiny canisters of fuel. The thing is, if you're somehow able to visualize the amount of fuel we used for natural gas power plant, that is mountains of fuel. If you can visualize that, because it's gas, you don't see it. In coal, of course, Singapore doesn't have coal-fired power plant, which I actually think we should have it. Then our citizens will really have the first-hand view on the mountains of stockpile you need in order just for you to power a small coal-fired power plant. And the amount of coal ashes that is flying around the power plant.
And the stuff that's going into the atmosphere.
Exactly. It is not just CO2, it's PM 2.5, PM 10 that is actually killing people.
Right.
Your asthma, your breathing problems, that all starts from there. And the thing is, if you go to Jakarta, you go to Bangkok, they didn't really have a blue sky as what Singapore has, right? So coal-fired power plant, that's what you get. And for nuclear, it's controlled. There's no emissions. There's no pollution. And the fuel amount is so small. Also, it's easy for us to do more stockpile of the fuel so that we can even further, make our energy security situation even better.
Yes, right.
So it is really one stone, multiple birds on energy security, on climate change, carbon-free energy for our industries. And also, one thing we should not forget is the kind of technology partnership and supply chain partnership that nuclear energy offers to Singapore. It's not just about a power plant.
Right.
It is about what do you get, right? There's sometimes people go with a conspiracy theory of Chinese-made solar panel, right? They say that, we are thinking of energy security, but you're buying panel all from China, and now you want to decouple from China. What you're talking about? And now when it comes to nuclear, interestingly, you say that, okay, now that we think that nuclear may also be supplied by one country or whatever, but in the end, if you look at the nuclear supply chain, it's a lot more complicated supply chain on the fuel, on the equipment, on the technology, and moreover, the international partnership that Singapore has also give us the ability for capacity building, training people, and also building up our regulatory capabilities, and also to make us more relevant in the regional dialogues on nuclear safety and nuclear energy development. So you see, Indonesia, Vietnam, and probably Malaysia are all looking to develop nuclear. So the question is, what does it mean for us, right? If you think that nuclear energy is dangerous, not in my backyard, but now somebody's backyard is actually a front yard, so what are you going to do, right? So if there's an accident in, hope there's not, let's say Indonesia or Malaysia or Vietnam, because Johor was one of the sites that was kind of looked at many years ago, we face the same risk. So the question is, then again, what's in it for Singapore to get involved, and what's in it not for us to not get involved? And so I think those questions are important, to looking at, for example, capacity building, share benefit, share risk, and also in the future, and this is what I always argue about, is how do we then further transform our national industrial economy to make sure we are still competitive? Right. We're already so expensive, right? So what next?
Interesting. Yeah. So thank you so much. Actually, we've actually run out of time, but this has been such an interesting conversation that we could go on and on about it, but we have to bring it to a close. And want to thank you again for coming. But I always try to end with a slightly more personal and interesting question for all of our guests here. And I have a weird one that came to mind because of how you started actually this podcast. If you had a chance to be a consultant on the Simpsons episode that we first saw what nuclear waste looks like, what are some of the things that you would tell them to change about how they portray it?
Yeah, I think one thing is change the color first. Let's go to blue. And then if it's nuclear waste, go to some of this waste storage site. They allow visit sometimes. Go have a look at how does nuclear waste really look like. Go there first, and then also have a visit to some of these nuclear facilities that allow you to do that. Bring a dosimeter and into the nuclear power plant and see whether it even moves right? You wouldn't even see it moving.
Right.
And then another thing is, if you talk about, nuclear power plant going to become a bomb, well, look at some physics, simple physics,
Sure.
and look at the difference between what goes into a nuclear bomb and what goes into a nuclear fuel, right? Just for layman, the nuclear bomb is 95, maybe even higher concentration of uranium. Nuclear power plant, 3%, maybe lower. So to detonate the nuclear power plant, you can, but you need real bombs to detonate it. Not on its own, it will never detonate.
Yeah.
So I think they really need to look at the science of it. It's difficult. I mean, that part we need to be fair. It's difficult to convey science, but if they can make it, surprisingly green, they should be able to make it beautifully blue.
So I guess, but they may not ask you to come back as a consultant when they realize that you are removing all the shock value from the cartoon that they've been doing. But anyway, thank you so much, Dr. Nian. It's been such a pleasure, and we hope to maybe have you back at some future stage for some other conversation topic.
Yeah, absolutely. Definitely happy to be back. Thank you, Jimmy.
Thank you so much.
Thank you.